Good morning. I'm going to label that as an expectant hush. As it falls quiet. Good news and bad news. The bad news is you've chosen the room with the less comfortable chairs. Good news is you'll definitely be out of here in less than an hour and a half, because I have no intention of taking that long. Okay? So, right. Guideline on implementation of design and execution, TGC4. I'm David Hard. I'm Chief Engineer at Bachy-Soletanche in the UK. The observant people will notice that earlier on it was Soletanche Bachy on the screen. I work for Bachy-Soletanche because in the UK we have to be different from French, so we just swap the name round. Same company. I am a designer. I've spent 30 years as a designer, but I work for a contractor. So every day of my career I have been involved with implementing design in execution. So for me, it seems kind of obvious, and I don't understand why people don't do it. However, a lot of people do get it wrong. But to be clear, this is not my report, okay? The task group had, I think I had about 22 names from 15 countries. I sent out meeting invitations, I hosted meetings, I nudged and adjusted when people had questions, and I did some editing at the end, but this is very much the work of the task group and not my personal report. Of course, if you think it's really good, it is all my own work, okay? So this is roughly what we're going to run through. Introduction to the report, why we even have this report, and then some of the stuff around concepts and plans and acceptance criteria. So, the background to the report. We were given a scope by EC7. It got tweaked a little bit at the beginning. This all started back in, I think it was December 2020. So this has taken quite a long time to get to where we are. I had a lot more hair when we started, and not all of it was grey. So we were asked to look at some just general guidance on implementing design. Okay. It actually includes, the full title is in execution and maintenance. But how do you maintain a pile? Okay, so it's generally referred to implementation of design in execution. We were then also asked to give some guidance on how you should implement the plans, because there was 1997, second generation, requires you to produce a whole bunch of plans as a designer. We're then, linking on from that, asked to look into setting out acceptance criteria and what those are and limit values, and then if you're going to set a limit, that implies that you might go beyond it. So if you go beyond it, what do you do then? But quite important to this is that point that it needs to cover all types of geotechnical structures we need to look at, and particularly small and medium-sized projects. For me, I don't see this as being a particular issue, this subject, on the big major projects. If you've got a big mega project, you're building metros, you're building airports, you're building dams, you'll have, I would hope, a mature enough design organisation that they are capable and competent to get it implemented during execution. I don't see those as being the problems. It's the small and the medium-sized projects where I think there's more advice required. And then, bottom line, a link to execution standards. Now, okay, I said I'm a designer. Who here would classify themselves as a designer? Who thinks they're a designer? Okay. Who would say they're a contractor? Okay. It's okay, we still outnumber you, the designers. Okay, so another question. Who here in the last week has used Eurocode 7 or Eurocode 2 or 1990? Okay, quite a few of you. Who in the last week has looked at an execution standard? Okay, that's more than I thought. Is anyone going to be brave enough to put their hand up and say that they've never looked at an execution standard? Okay. Yeah, I have my doubts. Purely because I've worked with colleagues that I know have never opened up an execution standard. Okay, I say to them, you do know that's in 1538, and they're like, what's 1538? It's the execution standard for the thing you're building. There is an implicit connection that if you're designing to Eurocode, you are building to the execution standards. Okay? And that is an implicit part of your design code you are using. For full disclosure, I am the UK representative on TC 288. Up here with TC 250, which is design. 288 is the technical committee in charge of the execution standards. And I am actually the liaison between 288 and 250, which is probably how I got dragged into this. So, however, as with any report, there are some limitations that I just need to make you aware of when we start off with. It's a guideline, not a specification. Okay? You can't waive it and say, it said it in this document, therefore it is a specification. Okay? It's a guideline that we've produced. It is complementary to the code. So we have to be very clear that we were not creating new content for the code. There were a few discussions around that because some people did want to try and sneak things in, bearing in mind that this was going on whilst the codes were still being written. It also has to be relevant to all countries, which again is quite a challenge because every country has its own national guidelines on how things get built and designed. So we had to somehow try and pick up that in the document. So we've tried to address and reference relevant documents. Some countries don't have them, but generally speaking, the UK, France and Germany do have their own documents. So quite often you'll find those documents being referenced in this guideline. But equally, it's not exhaustive, okay? Engineering judgment is something that, and I realise I'm turning into an old man, I'm starting to sound like my father, but engineering judgment is something that I see less and less of in younger engineers. So again, this is a guideline, we've got plenty of examples in it, but it is on the basis that you will be looking at those in the context of your project. Don't try and make your project fit our guideline, okay? Because that's probably not going to end well for anybody. So why is this needed? Well, within 1990 and 1997, there are requirements on the designer, this is all aimed at the designer, not the person building it, that you will have quality management in place, and that's in 1990. And in 1997, there's a specific clause around implementation of design. So you are obliged to do this. And so that's why this guideline has been created, because there was a feeling that actually people weren't quite sure what to do, and in fact the code is quite vague. It just says do it. So why is this important? Well, the design, yes, is covered by 1997, so you've got a nice design code, that's great. Good luck interpreting it. You need a really big desk by the time you've got all the documents laid out in front of you. The construction is covered by the execution standards, and pretty much all the different geotechnical types of structures have their own execution standard. There is still one being written for artificial ground freezing, but that's a bit niche. But everything else, ball piles, retaining walls, micro piles, displacement piles, anchors, everything has its own execution standard. So the construction's covered by that, but other than vague bits in each document saying, oh yeah, you've got to make sure that your design takes into account the execution, and in the execution standards there's a considerations in design clause that floats through all of them. There's never really been a particularly strong link. So in this second generation of 1997, there was a sort of an active thought, let's try and make sure that that link is created and reinforced so that it does happen, because I'm biased because I'm a contractor, but if you design something and you don't build it, all you've done is a very interesting theoretical exercise. Okay? The only reason for designing the thing is so it's built. So it has to be designed in a way that it can be built. So you need to make sure that the entire process is linked through. The guideline, this is just a run through what's in there. We've got a general section at the front covering all different aspects of the general background you should be thinking about. And then we have sections on establishing plans, and we've put in lots of case studies and examples. I haven't run through any of those in these because they're all in there. The version of the document that was sent out in advance of this meeting is the version which has gone to publishing. So other than them sticking a pretty front page on it, what you see is what you're going to get. So feel free to go through it and look at those examples. Because we try to pick up most of the common types of geotechnical structures that you're going to have in terms of looking at the plans. And then it's guidance and advice on the sort of things that you need to be thinking about as part of those plans. And then we've got a section on acceptance criteria, and we've got an annex with some checklists for the plans. So general principles. If you take nothing else away from this presentation, please take away that top point. Appropriate and effective communication. Okay? And it's a two-way process. Yes, you as the designer have issued your information to the site, but there's a few documents there which are classified as being live. The GDR is a live document, so you should be expecting information to come back to you from the site team, even if it's just in the process of giving them out the daily record. So it's a two-way discussion. Who is doing what and where do responsibilities lie? It's going to be very rare for a project to start off with the same team as it ends up with. And I'm not just talking about individuals, I'm talking about organisations. As you move through that project, different companies and organisations will be involved, which means you've got interfaces. So pretty much every problem that happens on a site comes down to people not knowing what they're meant to be doing, or people having different opinions of what they should be doing. Who's responsible? And you need to start thinking about this at the beginning of your design process. Don't wait until the contractor's been awarded and you've sent off a bunch of drawings to site and then going, oh yeah, we need to think about this, don't we? By then it's too late. So you need to be thinking about this as part of your design process. It might seem tedious, and it might seem a bit like, this is a bit like admin, isn't it? Isn't this document control? This is the process of how you get your design, because it's your design, built correctly as you want it. The contractor is not psychic, okay? I don't know what you want. All I've got is what you've given me. So if I don't understand it, I don't know what you want. So within the report, we said, okay, here's some key factors that we identified as being useful in successful implementation. Now, the key thing there again, common understanding. And then there's a list of items there. Because otherwise you can have two organisations and you both think you're talking about the same thing. You know, there's no malice in this, but you just don't have the same understanding of what you're talking about. So making sure there's that common understanding is a key to making sure that you get your design successfully implemented out onto site. So we've expanded some of the definitions. We've not changed the definitions, and we've made sure that the original definition is in there. Although maintenance, interestingly enough, although you are required to have a maintenance plan, there's no such thing as a definition of maintenance in the code. So you can literally make that whatever you want. We have given a definition for it, but so here, for example, is inspection. Again, inspection and supervision. What's inspection? What's supervision? Now, in some cases, you can merge them into one. on a small enough project, but we've actually given you an an expanded and clarified definition here with a bit more words in it to try and make it a bit clearer what inspection means. But at the bottom, and it's the same for all the different terms, if there is a code definition, it's there. So you can see code definition, 3 lines, 2.5 lines. We put a little bit more into it, and there's notes, just to try and make it a little bit clearer what inspection is, and we've done the same for quite a few of the terms, just to try and improve this common understanding. And some of those took quite a bit of picking through to get an agreed wording. But then also project phases. We've picked out, and there's a nice table, I didn't put on it here because it doesn't work quite so well on the screen. It works quite well in the document, but in the UK we have REBA phases, there's the ACE, in Germany we have the Hoyer phases, and it's standardised phases for a project. So, so if you're talking about REBA phase 2, REBA phase 3, it's a recognised stage of maturity in the project. And then you can also link the documents, which documents should you have ready at that point in time. If you're at stage 3, where is your GDR? Where's your GIR? Do you have those documents ready, and who's producing them? So we've just come up with a list, and we found about, globally, probably a dozen different methods of coming up with these phases. So we put in a table just to show how you can use them. And again, this is just, not to say you have to use them, or to pick them off, but if someone's talking about REBA and someone else is talking about Hoyer, you've got a method of going, okay, this is how they match up, and it's just a way of getting, again, okay, we're going to be at stage 3, and that's when I hand over to you, or at stage 5, and that's when you give me that document. It's just a method of breaking up the phases to a sort of an easy to understand process for everybody. Roles and responsibilities, however, now, we had quite a few issues as we were going through this guideline, and that some of the things we're talking about, you start verging onto contractual and commercial issues, and it's where it gets tricky. So we can't set out contractually who should be doing X in a project. That is going to be down to your individual project. There will be certain contractual rules that are set out, but you need to be clear in your project within that framework when information is being handed across. And so if we're saying that the designer is responsible for everything up to a certain point, and that might, the exact break point of that is going to change, is the designer going to take it all the way through and literally hand you drawings which you just take to site and build it? Do they give you design intent and the contractor then has to finish it off? Or is it a reference design that the contractor then does their own design and build? There's 3 different methods to get to the same end result. That's a contractual decision. But you need to be clear who is doing what within that, particularly if you start doing stages where the designer gives you a design intent that the contractor then has to finish off themselves. So what is that level of information and detail that's being handed over? And then what sort of procedures are going to be involved in terms of checking the information that's handed over internally and externally? Design risks, and again, this is one of the key areas. You as a designer have designed your structure, and you know that it needs to found within a certain strata, or it needs to form a cut-off, or it needs to extend to a certain toe level. You will have a set of criteria that you need. You will also have a vast amount of information, calculations, loadings, and everything that you've gone through to get to that solution. The contractor doesn't need all of that. What he needs, I say he, apologies, they need, is the relevant information to be able to build that structure. So if you say I need those piles to found 1 metre into that sand layer, they need to know that. Do they need to know everything that's above that sand layer? Not necessarily. Do they need to know why you've decided to go that depth? They might. But that comes down to this two-way communication, because if they start finding that sand layer at a higher level or a much deeper level, do they just keep, or they don't find it, they just keep ploughing on until they discover it? What is the process? So they need to be able to judge, are they still operating within your design assumptions, or do they need to come back to you and say, not quite sure what's going on here, what do you want to do? So it says, only the designer can assess what's significant to the design, because the contractor didn't design it. If you're a design and build contractor, you will have that, and you have that in-house, and that's what I do with our site teams. But equally, the site team doesn't know how I've designed it, so if they're not sure, they pick up the phone and call me. So the site, the construction team need to know when to pick up the phone. So, as it says there, sufficient relevant information to be able to proceed, but also know where's the whole point. So you need to know what's critical in your design in relation to execution, which is not the X thousand gigabytes of data that you've got sat on your computer. But that information also needs to be supplied in a format which the contractor can actually use on site. Geotechnics happens below ground. When we're installing that anchor, that dewatering well, sheet pile, whatever it is, we will have very limited information coming back about what ground it's gone into and how that relates to your design assumptions. So if you're saying, oh yeah, strata X or certain levels, can that contractor identify that on site? And that example at the bottom is something that I actually had in a project we were tendering, where we were told that the piles had to found, I forget the exact depth, 2 or 3 metres, into a material with an RQD greater than 50%. How the hell is the rig operator going to know that? Now, you could go, okay, we will put a borehole down every single pile location and take a continuous rock core out the bottom until we have identified what that is. Now, that is a method of solving that problem. It's going to cost the client a lot of money, which is fine if that's all agreed up front. So that's all possible. But just sticking that note on the drawing, I looked at that and went, how do we price that? Bearing in mind that the boreholes weren't actually deep enough and didn't go far enough, and some of them didn't even identify rock of that grade. So that I would classify as not a very helpful note. But that was critical, obviously, to their design. So, and this was at tender stage. We dodged a bullet, we didn't win that job. The feedback from the contractor on site that was doing the job is, yeah, they're losing a lot of money and it's not going particularly well. But that's an example of something which is key to your design, but has not been totally thought through in terms of how it's implemented. See, there are methods to implement it, but they're going to be time heavy and expensive. So, okay, point laboured. So, communication between parties. So saying communication is one of the key parts of this process. So, any project is going to have its own document control, admin procedures to go on. That's fine. So what we've done in the guideline is sort of say, okay, here's some good practice concepts that you can maybe try and take into your project. Now, these are points that would be worthwhile having. You may already have them. As I say, the big projects, they're probably already baked into the document control procedure. So things like design handover meetings, making sure you've got contact lists, who's responsible for what. Design coordinator, that will depend on the size of your project. But if you've got lots of different things going on, lots of different contractors, maybe you've got more than one designer. So do you need one person to just coordinate all of that and make sure that things aren't falling through the gaps? And then methods to deal with changes, errors and omissions, because we don't live in a perfect world. You get on site, things aren't what you expected. Things go wrong. Yeah. Put my hand up, we're contractors, we don't always get it right first time, okay? It happens. So what is your process for dealing with that in the design? And just writing contractors to submit remedial measures isn't necessarily going to solve the problem, is it? Because how does he solve a remedial issue if he isn't the designer? He's going to have to talk to you, so you need to think about these sort of things. And then the bottom point, okay, at the moment, pretty much everything I receive in the first instance comes to me as a PDF. It always used to be paper. But we've made that massive leap from a pile of paper to a PDF, which is generally not as helpful as it could be, because I then have to go back and say, well, that's great, but there's 1,500 piles on this job. Can I have that as an Excel spreadsheet, please? Because, you know, I don't want to have a graduate sat there for a day and a half retyping a pile schedule. So how are you issuing that information? Equally, people go, here's our rivet model. Boom, have that. Everything you need's in there. And we're like, you're great, thanks. Is there any kind of consistency? How do I know where to find pile loads in there? Because there's no uniclass method of identifying things like that. It's entirely down to how you have created your rivet model. So, again, a dumb PDF at one end and a massive, the entire project rivet model at the other. Yeah, let's, you know, what can your contractor use and what do they need? And just throwing all the information at them and saying it's in there, whilst technically correct, yes, you had all the information, is that the best way for you to make sure that your design gets built properly? And the answer to that is no. So think a bit about how that process is going to be managed. Equally, I know some people don't like handing over raw data because in construction, and certainly in the UK, it's a trust issue. And that's why you get handed a PDF, because if you get given the PDF, then you can't have meddled with it. Well, yeah, you can meddle with PDFs now. But if someone gives you a CAD drawer, a CAD file, or a rivet model, they're like, yeah, but you might have changed something in there. It's a trust issue. Maybe it's just the UK. We just, contractors don't get trusted. But think about that. So, okay, so then the plans, there's a lot of plans, but you shall, this is a requirement, you have to do this, create those 4 plans: supervision, inspection, monitoring and maintenance. A maintenance plan for a geotechnical structure, an interesting one. Depends what it is. If it's a spread footing, it's going to be a fairly simple maintenance plan. If it's an anchored retaining wall, it's going to be a fairly complicated plan. However, all the code says is that you have to do this. And that's the beginning and the end of the help you get given. Hence the guideline. It then also says that you have to have specifications to implement those plans, but this guideline is not covering specifications. We've deliberately stayed away from anything that is a specification. All we're saying is, here's some plans, this is the sort of information you should be thinking about, how you could implement it, but we've not got model specifications in this document, because it's just asking for trouble across national boundaries and it's contractual, so we've not gone there. You have to do them. They have to become part of the GDR. So again, you need to think a little bit about how they're going to be issued. Now, it could be a one-pager. There's nothing to say that one of these plans has to be a massive work of literature with multiple pages. It could be really simple, and you can combine supervision and inspection can quite often on a simple project be combined into one thing. So you need to look at your project and say, okay, what do we need to do? And you may find for some parts of the process the execution standard has already got everything you need in there already. Particularly if you're looking at some of the things like ground anchors, there's some very detailed information in there around the plans. So you'll probably find that a lot of what you need is already in the execution standards. Plus, you don't want to be writing something in your inspection plan that conflicts with the execution standard. Because then you've got a hierarchical problem in that the execution standard is the official code document, but you've now written something yourself contractually for your project which conflicts with it. So you're going to have to try and sort that one out. So have a look at the execution standards whilst you're writing these plans. If nothing else, it may save you some work. So we've looked at, doesn't cover everything, but we did examples for all of those different types of structures. So we felt within that we've probably covered the majority of the issues you're going to come up with. Some are more complicated than others. A spread footing example is obviously not a particularly large, complicated structure. Anchors and some of the embankment stuff, reinforced fills, it's a bit more complicated, particularly ground and anchors, because if you've got an anchor, you've normally got an associated structure with it. You're not normally going to build an anchor without a retaining wall. So there's a lot more to one of those examples than, say, the others. And then we put groundwater control in there, because that's the sort of the forgotten cousin sometimes. You know, everyone thinks about the physical drill a hole, fill it with concrete type stuff, but groundwater control is got its own clause now. So we made sure we had an example in there to try and cover that as well. Within each of those examples, we've tried to pick up all the standards that would be useful to look at for that structure. So we'll have picked off the execution standards and any of the other associated standards that you might need to go and have a look at to help you come up with that plan. And then there's some data, some geotechnical data about soil parameters, the actual geometry, there's a sketch, and then we put in some comments to sort of cover key aspects you need to think about. We also created checklists for the plans. Now, again, this was a big discussion because checklists are a bit double-edged. They're very useful as a starting point for a project. The risk is people don't bother thinking about their projects and it becomes literally box ticking. In the end, we went, no, we'll put them in because they are useful, because if we're trying to look at small and medium-sized projects, they should be helpful for designers in those situations. There's pages of them, because there's quite a few points to pick up on any particular structure, but we decided to put them in the annex as a sort of guidance checklists. But as we said, everything needs engineering judgment and everything needs to be tweaked to fit your project. But in the end, we came down to the conclusion that checklists would be a useful item to have in there. The other item we were asked to look at is acceptance criteria. So what are acceptance criteria? Well, this is how you're trying to judge whether your built structure matches your design. And we decided that there were sort of three essential types of acceptance criteria. So there's execution tolerances, you know, how out of verticality it can be, how far out of position in plan, just standard execution tolerances. Performance indicators, which are, is it behaving how we thought it would behave? You know, you've predicted wall movements, you've predicted pile settlements or embankment settlements, you've made some predictions. Or the third category is serviceability, which is how it impacts either itself or adjacent structures. So what is the most critical thing? Your pile is designed for, let's say, a wall movement of 25 millimetres, but are there structures around that can't tolerate that, or are there items around your actual structure itself that are critical, so you've got a very tight tolerance in terms of its SLS behaviour? So execution tolerances would normally fall within your standard specification. There's stuff in the execution standards. You might decide you want to tighten them up. You might decide, actually, you can live with some slightly looser tolerances. So those should be fairly simple to identify for a project. Performance and serviceability, this is linked directly to your design itself and the surrounding zone of influence, because there's not a universal set of criteria. You can't come up and say, okay, the pile should not settle more than, or wall should not deflect more than. It's not possible. So you're always going to need engineering judgment to set these criteria and also to adapt as the project goes along. So, as I said, the zone of influence becomes quite critical, because you should be looking not just at your structure itself, but you have to be looking at everything else in that zone of influence when you're looking at these acceptance criteria. If you're building in the middle of a green field, happy days, because there's nothing to worry about. If you're building a 6-level basement in the middle of a city, everything you do as that starts going on affects things around it. So you need to be thinking about your acceptance criteria, need to be reflecting what all of those other structures can tolerate. And so this is where you've got different aspects to serviceability criteria. If something moves too much and it cracks, is that just a case of that doesn't look very nice? People don't like cracks on walls, but it might just be the plaster's cracked. Is that actually a problem? You've got functional damage, whereby, okay, this is now moved, and this would be thinking maybe look about roads, railways. They normally have quite tight tolerances on gradients, so you might have gone outside the allowable criteria for that to be deemed to function. It's not unsafe, you just can't use it. And then there's, yeah, actually now this has moved too much and there's a safety issue. So what are those criteria you thinking about when you're setting those limits? Now, if you've got nothing else, fairly sure that's to say 1990, not 1190. I think I've just created a code. There is information on standard sort of, if you've got nothing else to work on, these are the sort of deflections and span criteria that structures will accept if you had nothing else from the designer. So you can fall back to that. Equally, a lot of national, especially railways and highways organisations, have their own documents around their type of structures, where they will say, this is the deflection we can live with, this is the maximum change in gradient, and so those will be setting criteria. So if you're working next to one of their structures, you will have to comply with their criteria. So you just need to be thinking about what in your country is applicable for you. So how do you set limits? What sort of things should you be looking at? So it's got to be something you can measure, and measure meaningfully. So normally you're looking at displacements and deformations, you might be looking at strains, you might be looking at vibrations. We did a job in the UK where we were next to the British Museum, which, if you don't know it, is full of things that the British Empire stole from around the world back in the good old days. And some of those items are literally priceless. You know, they can't, they couldn't get insurance to move them. So we had very, very tight vibration criteria because 3,000-year-old Chinese vase sat on a shelf. It's kind of, yeah. And yeah, they couldn't move it because that's deemed more risky than us piling next to the site. So we had vibration limits set that were undetectable to a human. We found out in the end that putting in the retaining wall was not the problem. We put in the secant wall and we didn't trigger anything. Excavators tracking across the site set every alarm bell off. It was to do with how the vibrations went through the ground and the footings that the British Museum was sat on. But that's an example of where a vibration was driving everything that was done on site. They were also very, very wary of anyone smoking on site. They really got very upset if they saw anyone doing that. So you have to choose criteria which identify behaviour deviating from your design, because you can pick all sorts of things to measure on a site. But what you need to bear in mind is these need to be the criteria that allow you or the contractor, depending on who's responsible for doing this, to pick up that, oh, hang on a minute, we're now moving outside the design assumptions. There's an old saying that came out of New Zealand many years ago, does it make the boat go faster for the America's Cup? And it's the concept of, if I'm asked to do something, what is the benefit to the project? If it's not benefiting the project other than you're just gathering some interesting data, why are we doing this? Okay, so make sure that the criteria that are being picked off to measure against are the right ones as soon as possible. Because if you've picked something that has to have quite a bit of movement before it starts registering, is that the right criteria to be looking at? So again, there's lots of different ways you can set them. We talk in the guideline about the traffic light system, because it's quite a common, most people understand traffic lights. Apologies if anyone's colourblind, because red, green, amber is probably less helpful to you. But it's a very common concept around setting limits. So you've got green, happy days, the project is doing what we thought it would do. You've got an amber limit, which is like, okay, we're now getting towards the limit of what we were expecting it to do. And then you would normally then have a red limit, which is, that's the hard barrier we do not want to go through. Because at that point, things have to stop, because we're now into the territory where something is going to be unsafe, something's going to get broken. Now those limits, they could be based on your predicted behaviour, or they might be set on the serviceability limit. So you might say, we've got a limit based on how much the wall deflects, that's your prediction, or you might say, we can't accept more than a certain amount because otherwise the adjacent structure will be damaged. Where you set these limits is, again, this is this dangerous engineering judgment, but some typical ideas might be that, because if you set limits too low, you breach them too early in the project, and that's not helpful, because all you've done is you've gone sailing through the limit, everyone agrees it's okay, and you carry on. So what was the point of setting that limit in the first place? If you set them too close to the edge, you've removed your room to manoeuvre to get out of the problem if it starts occurring on the red limit. So an amber, you want to be setting at the point where, okay, it's starting to behave a bit beyond what we were expecting. So do we need to start thinking a little bit about what this is doing? The red limit needs to be, if you set a red limit too low or too small a number, it becomes meaningless. Because I've had projects where they've been set and you go straight through the red limit and everyone goes, yeah, but nothing's happened. Everything's fine. So hang on a minute, why was that set at that limit? It depends on what you're monitoring and why. And those limits are quite often determined by the surrounding assets, not your structure. So you are reliant on third-party information to get these set correctly. You will also potentially have to adjust these as you go along during your project. You need to have a certain amount of flexibility in there, because if the structure's not behaving as you expected, which could be better, there's nothing to say it has to be worse. Things might be behaving an awful lot better than you thought. And okay, actually, we could change our construction sequence here. There's opportunity, not risk. And I say in the most extreme case, that's the observational method. You're adapting as you go along. We're not looking at the observational method in this document because there's plenty of guidance on that, and that's a very specific, specialised method. If you want to look at the observational method, you need to be looking at the guidance documents particular to OM. But when you set the criteria, it's to say you need to think about what is the negative behaviour, what's the impact it's going to have. Because if you say, I need you to stop when you reach that limit, that automatically on a project has a cost and time implication. So again, you don't want to be setting them too low, but then you also need to make sure you've got time in there for any contingency to be implemented. And also, how close to the edge can you go? If you set a red limit, how comfortable are you that if you hit that, and nowadays they can literally be so that someone's phone will ring at 3 in the morning, you know, real-time live data is being monitored, and you breach the red limit, someone's phone rings, and plan swings into action. You know, has that person already been awake worrying because they're concerned about something falling down? You know, where is that limit being set? So the implications of that, breach of these triggers will depend on your project, but if you go through a green trigger, that's not normally considered to be an issue, because all that means is you've gone from within what you'd expect your structure to be doing. Okay, let's just have a little look and see what stage in the construction sequence are we. If we're just starting the project and you're already starting to meet into your criteria, you might think, okay, this is a bit odd, what's going on. If you're getting towards the end of your project, when you would expect to be getting towards the limits, you're probably not too concerned. If you go through the amber trigger, we're listed out, and again, these are guidance. This is not a specification, you shall do this. These are things that you probably need to be thinking about. And one of the first things we said on there was, okay, sanity check your measurements. Are you sure that your monitoring equipment is telling you the truth? You know, what are you using? Are you using a bloke going out with a level, someone lowering inclinometers up and down tubes? Is it electronic? Is it, you know? So first thing, just have a look. Is it a rogue reading? Has someone transposed the values? So, and then, okay, you believe the numbers, so then, you know, have a look. You know, are there signs of distress? Is the structure that was dictating the behaviour of this limit, is that actually looking like it's got a problem or not? Notify relevant parties, you might need to, you might not to at this point. And then this is where you start looking at where am I in my design, and if it's doing, you know, the wall has moved 20 millimetres, I was expecting it to move 25, do I need to look at my design parameters, or is it, okay, this is the final excavation stage, it's going to be sat there for another 2 months, we can monitor it, it's not a problem, it's far enough into the project that we should be getting towards the limit. If you've only just started, you've probably got an issue. So you need to review and look at your design and see where in the bigger picture of the sequence does this information fit. And then possibly you need to start thinking about, if this is a problem, what do I need to do in redesign? Not saying you have to do it, but you need to start thinking about that process. generally speaking, if you go through a red trigger, the first thing that happens is nothing, because everything stops. Okay, because that's normally the O expletive. We need to have a plan in place, and this is where, you know, additional props start being brought back in. You're backfilling your excavation. You know, this is a problem. Okay, if you've gone through a red trigger, unless someone set a red trigger level which is artificially low. So stop work and assess. Everything gets, you would be expecting everything to be inspected. You might be restricting the use of your adjacent assets. And at this point there should be an action plan. You know, in case of emergency, break glass. This is the point where you break the glass. And you might be finding you have some discussions with the client, third parties, and these might be awkward conversations. So in conclusion, communicate, okay? The designer and geotechnical contractor need to be talking to each other. You have obligations under the code to link to execution, so you need to make sure that those obligations are being met, but the execution standards may already help you. Early engagement, I'm very biased on this because I cannot stress strongly enough that early discussions between designers and contractors can remove an awful lot of problems when you actually get round to building the thing on site. Because the geotechnical contractor is the person that understands how to build the thing that you want. So early engagement is critical in geotechnics to make sure that you have the right solution. The plans are down to you as the designer to come up with. So, you know, you've got blank pages. So the level of detail is going to depend on your project and what you think you need to hand across. And we've given you a suite of examples to play with that hopefully will help you do that. And then when it comes to the acceptance criteria, you need to be thinking not just about your structure, but what else is in the zone of influence. And I appreciate that trying to get information from third parties on other structures can be difficult. Hakan was talking about uncertainties earlier on in ground models. These is probably your biggest uncertainty. The building next door, when was it built? What foundations are it on? The client's lost the drawings, they don't know. How do you assess that? And then your trigger levels, or whatever system you come up with to manage these criteria, need to be set at appropriate values. And again, you're the designer, so you will know what's appropriate for the structures, but you need to probably be talking to the contractor so that they can go, okay, yep, that's something that's fairly standard, we can implement that without any additional cost, or have you asked for something which is going to result in a bit of a Rolls-Royce solution being wheeled out? Again, it can be done, but it's cost, and that cost goes up to your client. So again, if you understand all of this at the beginning of the process, the client doesn't get any nasty shocks later on when you try and get this implemented. Thank you. Any questions?